7th graders, let's go through lesson 2-1 today. Yes. Listen up. We're going to start with some properties of numbers. Okay? These are some rules that you'll be able to use when you're doing algebra. These are rules of the game of math. One of the rules is that you can switch the order of the numbers and get the same answer. So, if you don't want to do 5 plus 3, you can do 3 plus 5 and get the same answer. Okay? Or, if you don't want to do 5 times negative 3, then you can do negative 3 times 5 and get the same answer. In other words, the commutative property says that you can reverse the numbers or switch the order of the numbers whenever you're doing addition and multiplication. It doesn't work for subtraction or division. Obviously, you can't do 5 divided by 1 and change that to 1 divided by 5. Okay? Or you can't do 10 minus 5 and get the same answer as if you do 5 minus 10. But for addition and for division, for addition and multiplication, you can. That's one of the reasons why I taught you when you're doing subtraction to insert a plus sign. When you insert a plus sign, the minus sign goes with the number, and then you can move it to a different spot. It allows you to move it to a different spot by inserting a plus sign. Okay? Now, don't start on your worksheet yet, okay? Because there's a certain way I want you to do these problems using mental math and using some of the rules that I'm teaching you right now. So just wait with that. Now, I wrote here, the number commutes to a different location. That's one of the ways to remember the commutative property. Sam, sit down. The associative property. State your guess, okay? The associative property, most of the time it contains parentheses. Alright? Now, notice in this example, 5 plus 3 plus 1. If we were just going to do this problem, we would work it out in order from left to right. But the associative property says that since this is all addition, you could do 3 plus 1 first. In other words, you could put parentheses around 3 plus 1 and do that first. Is the order different, Max? No, the order of the numbers is not different. It's the order in which you would do the addition that's different. So in this one, you add the first 2 numbers first. In the second, you add the second 2 numbers first. So remember, people get confused with the associative and the commutative property because they look for the parentheses. But it's not just about the parentheses. It is about which numbers you add first when the order is the same. That's the associative property. When the order of the numbers is the same and you add 2 different numbers first. Okay? Let's go on to the multiplicative identity property. My favorite word in math, multiplicative. It's just fun to say. Multiplicative. Or sometimes the boring way to say it is the identity property of multiplication. I'd much rather say multiplicative identity. In other words, if you multiply any number times 1, you get the number you're starting with. 5 times 1 is 5. Negative 3 times 1 is negative 3. N times negative 1 is n. Any number times 1 is the same number you started with. Okay? So it identifies the number. It identifies the number by multiplying it by 1. Okay? There's an additive identity property. The additive identity property is that any number plus 0 is its identity. Or any number plus 0 is that number. Okay? That identifies the answer. We're going to be using this a lot. We're going to be using these two a lot when we're solving in algebra, when we're solving equations. This is a step that proves that 5 is 5. Okay? You might be thinking, why do you have to prove 5 is 5? We know 5 is 5. Well, there's a lot of rules when you're proving numbers. Just like there's a lot of rules if you're a lawyer in a courtroom, there's a lot of things like objections that you have to know about. Okay? There's rules in math you have to know about. There's rules in algebra you have to know about. And that's one of them. Now, on the worksheet today, we're going to be using mental math strategies and some of these rules to solve these questions mentally. So on the first one, number 1, it gives you the numbers 3 times 20 times 13 times 25. 4 times 13 times 25. 4 times 13 times 25. Now, if you have 4 and 25 and you're multiplying them in the problem, it would make sense to multiply those first because it makes what number? 4 times 25 is what, class? 100! Come on, it's not that hard. It says on the board even. It says 100. Okay? And that's a lot easier than multiplying 4 times 13 and then multiplying it by 25. So by knowing that we can switch the order of the numbers using the commutative property, on the first one, you can do 4 times 25 first, and then times 13. So I want you to circle 4 and 25 on number 1, and write 100, and then write times 13 is 1300. You have to write this, you have to circle 4 and 25 and write 100. Yes, that's why I said don't start this until I tell you. So you write 4 and 25 and write 100, or circle these two and write 100, times 13 is 1300. Circle 1300. Okay? Do you get why this is 1300? Good, good. Do you get why you would do 4 times 25 first?
Yes.
Because it makes 100, right? It makes a power of 10. Another strategy that you're going to use is adding 2 numbers first. Now, when you look at 3 and 7, what do you think?
10.
Yeah. Now, there's different ways to make 10. 4 and 6 make 10. 5 plus 5 is 10. 1 plus 9 is 10. What you're going to do when you're adding numbers is look for those numbers that make 10 first. Okay? Look for numbers that make 10. 700 and 300 make 1,000. So circle these first and write 1,000 plus 127 is 1,127. Circle that. And that's how you would do this mentally. Okay? 700 plus 13, I'm sorry, plus 300 is 1,000 plus 127
is 1,127.
Good. I didn't lose you.
But how do you have to make it into a like 100 or 1,000?
Yes. Yeah, that's
So
the point of this. Is to
what you're
make
trying to do for your first step.
correct. Yep, that's what you're trying to do for your first step, is make a number that is a power of 10. In other words, make a 10 by adding 7 and 3. Make 100 by adding 70 and 30. Or in the next one, which two numbers go together to make 100? We've got 68, we've got 85, and we've got 32. Look at the ones place. Which of these make 100? Which two numbers go together to make a 10? Caleb? 8 and 2. These make a 10. So combine these, and that's 10 and 90, because 60 plus 30 is 90. 10 and 90 is 100. Okay. Or 68 plus 32 is 100. So circle those first. And then add 85, which equals 185. Number 4. 2 times 3 times 4 times 5. Multiply to make a 10 first. Multiply to make a 10 first. Sam?
4 times 5.
4 times 5 makes 20.
Oh, 2 times 5.
2 times 5 makes 10.
What is
10 times 12. 120. Okay. Number 5. Negative 14 plus 71 plus 29 plus negative 86. Look at the ones placed in each number and make a 10. Which numbers, which ones combine to make a 10? Sam?
Negative, the 6 and then 86 and then the 4 and the 4.
The 6 and the 4, and they're both negative, so we can add those to make negative 100. Are there any other ones that add to make 10? Look at the ones. Which other ones make 10? Emily?
1 and 9.
1 and 9 make 10. So add those two together. 71 and 29 makes 100. And these are opposites. Okay. Any questions on this process so far? Skip number 6.
Whoa, let's get it. I already did.
Well, that's fine if we do that anyway, but we're going to go on to number 7.
Yeah, it was easy. Wait, so you don't even have to do this in our worksheet?
Just stay with me. That's why I want you to do these in a certain way so you're learning a process, okay? I don't want you to work ahead of me because I want you to show them in a certain way because you're learning a process, okay? Combine the numbers to make a 10 or 100 or 1,000. Which numbers combine in this one, Adam? 20 and 5 make 20 times 5. 100. So circle 20 and 5 and write 100 times 7. Write the answer. Okay? Skip number 8 and do number 9. We can either do this together, otherwise I'll just assign the whole worksheet. Okay? Come on, stay with me. This isn't that bad. It's just to get a 20 puzzle. What numbers can you combine to make 10, Reese? 9 plus 1 makes 10. So 11 and 39. You can do this.
21.
Come on, Asa. Close. 50. It makes a 10, right? 50 plus 27. And 50 plus 27 is easier to add together. Yep. You understand?
Yes, I do. And everyone else here.
Good. All right. Look at the back, the bottom section. Number 13. What is mixed up in the order for number 13? 14 m and n is equal to 14 m times n. Oops, I'm sorry. What's different about the second one? Asa?
The second one has an N on the outside of the parentheses.
Yeah.
Yeah.
So what would you do differently in the second one? AJ? Are you listening? Pay attention here. Look at the second one. What's different about the second one? Is the order of the numbers different? No, the parentheses are in a different spot, meaning that instead of multiplying m times n first, we would multiply 14 times m first. Which property says that? Which property is that? Luke? That's the associative property. Okay? That's the associative property. Number 14. That's 13. 14. 19 plus 11. Stop whistling. Equal to 11 plus 19. What property is that? Great. That's correct. Commutative property of addition. So you have to write commutative property. K times 1 equals, what is it? K. What property is that? Come on, it's my favorite one. Yes! The multiplicative identity property. So go through and match those. Look back at your notes to review those properties and do 13 through 22 for tomorrow.